Hi everyone, today we are going to discuss a diagram, not one diagram, two diagrams. This academic task one, it's not a classical task one, and this is a diagram, it's a picture. It shows the structure that's used to generate electricity from wave power. So we have two pictures here. Picture number one is marked as A, picture number two is marked as B. And what exactly is happening in A and what exactly is happening in B. And this is what we are going to assess today. Now, let's see how what all the things which are going to happen here in this A. So we can see a chamber here, and this chamber is shaped like this. And this chamber may be glass or steel. I don't know what it is made of. It is fixed to a sea cliff or a sea wall, a place near to the sea. So it is attached there. Now what we can see is that the waves are coming inside the chamber, and this is a natural process. So it's quite natural. Waves approaches the seashore. So when the waves approaches the seashore, the air in the chamber is pushed out forcefully out of this turbine in a clockwise direction. And when this turbine moves in a clockwise direction, electricity is generated. The air escapes out. This is what we can see in picture number A. And what we can see in picture number B is that, so when all the air escapes outside, the waves retreat because it's a natural process. The waves have to retreat. It pulls itself to the sea back. This is the force. As the waves retreats, what happened is that we can see the air, the atmospheric air is pulled inside the chamber. And when this negative pressure is created inside the chamber, the air is pulled inside. And this also turns the turbine in the same direction, and then electricity is produced. So this is what we can see here. Now, okay, now we can start. Okay, now we have to write the introduction of this particular task. Now I'm going to frame the introduction here. The way in which a structure which generates electricity from wave power is elucidated in the given pictures. overall, it is clear that overall, it is clear that the system's functioning depends totally on the waves and the process is continuous. Now I have to frame the first particular paragraph. Let me frame the first particular paragraph. As the waves approach the chamber, so I can add one more sentence here. It's clear from the diagrams that the whole system functions smoothly with the placement of a large chamber, which is closely constructed to the sea wall or the sea cliff. As the waves approach the chamber, the air inside it is pushed upwards through a narrow column. Through the top of this column, towards the top of this column, I have to say Ukvi. Halfway up this column, a turbine is placed, which rotates swiftly in the clockwise direction when the air escapes Forcefully. That's enough. Forcefully. Already we have mentioned upwards in the previous sentence. This rotation, this swift rotation of turbine converts the mechanical energy of the turbine converts mechanical energy to electrical energy. So the first paragraph is framed, the first chart is explained. It's clear from the diagrams, both the diagrams, that the whole system functions smoothly with the placement of a large chamber, which is closely constructed to the sea wall or cliff, which is constructed. Yeah. It is constructed very close. That's enough. Now, I have to move to the second diagram. I'll place it here. As the waves retreat, a negative pressure is automatically created inside the chamber, which pulls in the atmospheric and air forcefully inside the large chamber. Here too, the turbine rotates at the same speed and in the same direction. This ensures that the generation of electricity is not uninterrupted. That's it. This ensures the generation of electricity ensures the uninterrupted generation of electricity. That's why this ensures the uninterrupted generation of electricity. That's it. Now I have completed this thing here. Let me see whether I have satisfied my word count. Yes, it is 161. I have completed my word count. The way in which a structure generates electricity from wave power is elucidated in the given pictures. So the way in which a structure generates electricity from wave power, you can see that how electricity is generated from wave power. Overall, it is clear that the system's functioning depends totally on the waves. You can say that functioning depends totally on the waves. And the process is continuous. And the process is not stopping, it is continuous. Whenever the waves are approaching the sea cliff, the electricity is produced, is generated. It's clear from the diagrams that the whole system functions smoothly with the placement of a large chamber, which is constructed to the very close to the sea wall of or the cliff. So I have to write something else to make it a little bit. I need to upgrade my language. It's clear from the diagrams that the whole system functions smoothly. Okay, okay, now the system functions with the placement of a large chamber which is constructed very close to the sea cliff. As the waves approach the chamber, the air inside it is pushed upwards through the narrow column. Halfway up this column, a turbine is placed, which rotates swiftly in the clockwise direction when the air escapes forcefully. This swift rotation of the turbine converts mechanical energy to electrical energy. As the waves retreat, a negative pressure is automatically created inside the chamber, which pulls in the atmospheric air forcefully inside the large chamber. Pressure is automatically created inside the chamber. I don't need this chamber because I have already mentioned chamber. So this large I can add here. Here too, the turbine rotates at the same speed and in the same direction. Which ensures the uninterrupted generation of electricity. So I made it complete. So I have completed this thing within around 150 words. The word count is there. So the explanation, introduction is there, overview is there, and then 2 paragraphs. The first picture and the second picture is there. I hope you must all understood this picture. Thank you, one and all. Have a nice day.